This meeting is being recorded.
That was aggressive. Hello, everybody. Welcome. Thank you for joining us for the American Cetacean Society Orange County Chapter webinar this evening. We have Jessica Crance, who will be speaking momentarily. But first, since we had a huge event or big event, unfortunately not uncommon in our waters with a gray whale entanglement, we have one of the people who was well, I'm sure several of people are here that are logged in and watching this now, but Gary was right in the middle of the action. And so we're just loading up his photos, and he'll be speaking to the now unentangled whale, which is fantastic. Okay. How's that going, Hannah? 1 minute. We can sing 99 bottles of beer on the wall. Or no, we're ready to go. Yay. So Hannah's just getting all of these. You get a chance to see what this looks like. And I haven't heard anything. Has anybody seen him since, him or her?
No, and I mean, in a way, that's a good thing. We don't want to see, let's just say her, we don't want to see her anywhere down here. We want her to be hustling it back up to her food in the Arctic. So, and because the team removed everything on her tail, you know, unless she fluked and somebody really knew what to look for in terms of scarring or wounds on that tail, you know, I doubt anyone would see her, and that's not a bad thing.
Okay, Gary, I think I got it ready for you now. So,
Okay.
so this is Gary. He is a naturalist from our class before last, when we were still meeting at Ocean Quest. So our naturalist class, where we train, you know, anybody and everybody who loves whales and dolphins can become a naturalist, and they take this course, and a lot of folks end up volunteering on boats. And in Gary's case, he was a captain, and he now works with me at Captain Dave's Dolphin and Whale Safari in Dana Point as a naturalist and captain. So super cool that he got to use the knowledge he learned in that class to bring that knowledge to his job now, which is super neat. But we wanted Gary to come on and talk because it's just so cool that one of our naturalists got to be really a part of this disentanglement. And so Gary, if maybe you'll just take a few minutes and kind of walk us through what happened, you know, getting on the scene. What did it feel like to see that? You know, what did the whale look like? Kind of what did they, who else was there, you know, as far as the disentanglement team and how it went. And yeah, that would be great to hear your story. And I'll do my best to go through your photos in order, but I don't know if they'll be in order, but I'll try.
Sounds good. Thank you.
Go for it, Gary.
Thank you. Can you hear me?
Yes.
First of all, ACS, that's the best class I've ever taken in my entire life. And I've taken a lot of classes. So thank you, ACS. You guys are amazing, and I brag about you and refer people to your class all the time on our whale watch trips. So last week, Monday, June 13th, a whale watch boat out of Redondo Beach was the first boat to spot this poor juvenile gray whale moving extremely slowly and headed down. So not typical to see a gray whale in our area, Southern California. This time of year, they're supposed to be all back home or on their way home to the Arctic. And so that boat knew it was unusual, got a closer look. They got some drone video and found, you can see there, Hannah has the picture loaded of this poor gray whale, severely entangled all around its fluke or tail. And you can see there, it's got gill nets super nasty stuff, pieces of lobster traps, weights, lines, hooks, all around its tail, stalk, and fluke, wrapped dozens and dozens and dozens of times. So that was last week, Monday, June 13th. So in the whale watch and boating community, mainly whale watch communities, that word gets out. NOAA was notified. So all of our captains down in Dana Point were expecting that whale and hoping that we could get, hoping that we would see it. So 2 days later, Wednesday, June 14th, 10 a.m., a Dana Harbor fishing boat already knew about it and did relocate it, swam right by him. So really, really fortunate that it was so close to the harbor and that it was spotted at 10 in the morning. There are so many factors that have to align to help an entangled whale. Rescue team availability, time of day, location, type of gear on the whale, severity of entanglement, whale behavior, sea conditions, all of these things have to line up perfectly. If that boat saw this whale at 5 p.m., it would have been too late and we would have lost daylight. So the 10 a.m. was magic time of day. So SeaWorld has special entanglement teams, which is pretty nice. It's good they're now giving back to our animals. So they were alerted. They're all on call. So at 10 a.m. they were alerted, and then Pacific Marine Mammal Center, they also are pros in whale disentanglement. They were alerted. So that takes time to get the SeaWorld people and everybody up to Dana Point Harbor. They all got there about 1 p.m. So for those 3 hours, and again, the teamwork involved was just absolutely incredible. So all the whale watch boats tag teamed this whale so we didn't lose sight of it. So for 3 hours, we all had boats full of passengers going whale watching. Everybody just stopped everything and we made sure there was a boat on that whale until the team got out there. So the team got out there shortly after 1 p.m. It took 3 hours to disentangle it. It was led by SeaWorld whale rescue expert Keith Yip. He's been doing whale disentanglements for 30 years. He's a top level 4 rescuer. It's a life-threatening work. I saw him risk his life to save this whale. He's helped partial disentangle 100 whales in his 30 years. So they first attach big buoys to slow the whale down. Satellite locators, they attach it to the gear that's hooked around the whale in case we lose it, or if they're not able to finish the job that day, they can try to find it easier the next day. So what they do is they attach a knife and a pole to the gear that's on the whale, and usually whales move at a decent speed, which kind of self-cuts off all that gear. This whale was so kind of emaciated from lack of food for so long, it wasn't moving quick enough. So what's his name? Keith Yip, he came back to our boat. We had all their gear, and he said, I'm just going to go hands-on, which is something he's almost never done in his 30 years, only a couple times. But he said that this whale has no hope unless he does it. So Hannah, if you could load that picture of him leaning in the water. Yeah. So that's it right there. The whale is they're on top of the whale's tail, and he just had a hand knife and made 75 cuts, just cutting and cutting and cutting and cutting. If that whale were to have jumped up or moved erratically, it could have taken some of their lives easily. He took the risk also because the whale was so tired. He was just hoping the whale wouldn't do any erratic movements. but you see him there risking his life. Kind of emotional. It was just incredible. He got it all off. He got every little bit off. And there you see some of the buoys they hook up to the gear on the whale. And then you see all the stuff that they got off. Absolutely incredible. So it was a complete disentanglement. Our boat, the Captain Dave's boat, we followed the whale after they got all the gear off, and the whale popped up next to us, and it was a pretty special moment. And the whale then went from heading down, which is the wrong way, down to Mexico. There's no food down there for it. It turned around after all the gear was off, picked up speed, probably the fastest it's moved in weeks and weeks, and then started heading back to the Arctic, where its food is. And we took all the gear and stretched it out. I don't know how much it was, but you can take a look there. A ton of gear that was probably, they're guessing, was dragging that whale down for weeks, if not maybe months. And the stress involved with that is terrible. So I asked Keith Yip, now that he's free, because he's so hungry and super thin from lack of food, what are his chances? And he said he gives it a 30% chance. So it was 0%, and you know, that's not bad. A 1 in 3 chance this whale might actually make it. So it was incredible experience to watch that.
Well, thank you
Gary
so much.
Thanks for sharing. Your photos are amazing.
Yeah, and you can see there's a photo of the SeaWorld van that they pulled their rescue boat, and then Pacific Marine Mammal Center's boat. They were incredible. One of the veterinarians at Pacific Marine Mammal Center was there in their boat. It was just really incredible. The guy who runs the towboat service out of Dana Point, he stopped his whole work, stopped everything, turned on his lights, and did a perimeter of the whole area, keeping private boaters away, which was critical too. You know, everyone wants to take a look. The last thing these guys needed was to spook that whale when they were kind of hands-on top of the whale. So everybody stopped what they were doing. I would say 25, 30 plus people all came together to save this whale.
Great. Thank you so much for sharing that. Thanks
Yeah,
to everyone
absolutely.
involved, especially Natalie, who first spotted the whale and told Elisa. She got the ball rolling. I want to give her a shout out for that one. Okay. Now I'd like to just spend a minute when I could speak for 2 hours about the amazing, incredible Jessica Crance. I believe I first met you over drinks and dinner prior to you speaking for ACSLA's chapter, but Bernardo, I think, moved it to work at the aquarium in Santa Monica, right, with Heal the Bay, which was fantastic. And it was all about right whales. So Jessica, I don't know if you have a Miss Rome, not Miss Crance, if you have a second. There we go, to get the right view in now. And she spoke about the plight of the North Pacific, the Eastern North Pacific. Well, yeah, Eastern North Pacific right whales. And we're going to hear all about it. She works for NOAA. She's a diver. She likes to play volleyball. She is the cheerleader on all expeditions and keeping up the morale, I hear, for everybody who works with her. And I'm sure you will be enchanted, even though she's battling COVID. So send good thoughts her way that she didn't cancel this and she's powering through, and maybe limit questions so she could go to sleep and get better. Okay.
Yeah, thanks so much. Yeah, apologies in advance for the hoarse voice, the coughing, the lots of taking tea and water sips. As Dareth mentioned, I am battling COVID at the moment. But thank you so much for letting me be here and talk to you guys. I honestly could talk about right whales for hours on end. I'll try and keep it to a reasonable time frame, just so I'm not keeping everyone here super late. And it's especially hard after coming from such an amazing, heartwarming story as, you know, disentangling a gray whale to a somewhat less heartwarming story about right whales, but hopefully you guys walk away from tonight learning a little bit more about them. So these first few slides are most likely going to be review for everyone here, but for those that may not be familiar with right whales, I'm going to go through just some of the basics. They are a large baleen whale. They can grow to approximately 50 to 60 feet long. And so here they are kind of relative to a human. They are filter feeders. Obviously, they eat zooplankton, predominantly copepods, also euphausiids. I would absolutely be remiss if I didn't talk specifically about how to ID a right whale. Again, even though I'm sure you all know, but they are big, fat, and dark in color. They have no dorsal fin. So if you see a whale out there that is all of those things without a dorsal fin, it's a dead giveaway. They do have the callosities, or those white patches on their heads. When they surface, they do make a very distinctive V-shaped blow. It can often be confused with a gray whale blow that's more heart-shaped, but if you do get a really nice shot like this photo here, you can really clearly see the two different spouts. Their flukes are really wide, clean, and triangular. They've got that really nice deep notch in the middle. And their pectoral fins have this really kind of unique shape to them. And then I like to mention that if you see a whale and you find yourself saying, well, that's a funny looking gray whale, humpback whale, fill in the blank, odds are it probably isn't a gray whale or a humpback. So it's definitely worth another look. So you mentioned those callosities you all know about. Well, the way we tell individual right whales apart is through their callosities, right? So that the pattern of callosities is unique to each individual right whale, much like humpback whale fluke. So if you look at these four photos, you can see that the callosities on each one are all very different. And so this is how we tell individuals apart. And then by comparing these photos to our catalog of known individuals, we can tell whether it's a new animal, we can track individuals over time, we can get an idea of recite rates and population trends. And then I always kind of like to show the photos of right whales side by side with other species that they are often confused with. Our right whales do tend to associate very heavily with humpback whales and fin whales. And potentially gray whales as well. So I really like this kind of nice side-by-side shot here where you can see the difference. Again, I'm sure for everyone here, this is a repeat of what you already know, but just in case we're dealing with the West Coast where our right whales are obviously not common, I had to throw it in. So there are the three different species of right whales. You've got the Southern, the North Atlantic, and the North Pacific. The North Pacific population feeds in the Bering Sea, Gulf of Alaska, and Russian waters during the summer months. And the North Pacific population is separated into two different stocks. The Western stock, which is found primarily in Japanese and Russian waters, and then the Eastern stock, which is in the US and Canadian waters. And studies have shown that these two populations are genetically distinct. So even if there is some spatial overlap between the two populations, it doesn't appear as though they're interbreeding at all. And so the Western population is thought to number somewhere in the low hundreds of animals, maybe 300 to 500 or so. But for the rest of the talk, I'm going to be focusing on the Eastern stock, or the right whales that are in US waters. So right whales were once widely distributed throughout the entire Bering Sea and North Pacific. And then they did unfortunately become one of the primary targets of Yankee whaling in the early 1800s. And it's estimated that between 26 and 37,000 animals were taken, with the majority of that taking place in only a few decades. And so this brought the population down to what we think were maybe the high hundreds or so. And it was thought that the population was beginning to recover, but then the Soviets came in and began illegally whaling in the early 1960s and just decimated what was left of the population. They took over 700 animals in just a few years, and brought the population down to what we think are its current numbers. So what is that? What is the current population size? So this map shows all of the sightings of right whales in the eastern population from 1980 to 2003. So in 23 years, this was all they found, despite some pretty dedicated surveys. And so they then conducted additional surveys in the early 2000s to try and get at abundance estimates. And what they found with those data was a population estimate of only about 30 animals. So there are roughly as many people on this Zoom call right now as there are right whales in the eastern stock. And of that, only an estimated 8 are females. And of those, it was originally thought that the sex ratio was roughly 2 males per 1 female, but then a recent study showed that the ratio is actually more than 3 males per female, which unfortunately is the opposite ratio you want when you're trying to rebuild a population. The one good thing about this is that study also did show, though, that despite their really low numbers, there does remain pretty high genetic diversity within this stock. So there is some good news there. So because of their low population size, a couple areas in the southeastern Bering Sea and near Kodiak Island were designated as critical habitat for right whales in 2008. So we know that they can be found in these areas in the summer every year. But what we don't know is where these animals go, when, or even if they leave their feeding grounds. Their migration routes and calving grounds are still unknown. You know, even whaling logbooks, if you go back through historical whaling logbooks, they mention that there was no evidence of breeding or calving grounds. And so while we suspect they migrate south in the winter, like many other large baleen whale species, we have no idea what those routes are. So you can look at some of the historical sighting data to try and piece together their migration routes. A couple dozen sightings in the past have occurred in Southern California and Baja. The map on the right here shows the sightings from 1968 to 1999. So you can see a handful of them there along the coast. And then there was one high to low latitude match of a right whale that was first seen in Hawaii in April of 1996. And then was later resighted in the Bering Sea in July. And so this was the first and is still the only evidence of a migration of a right whale, because none of the animals that have been sighted along the West Coast have ever been resighted anywhere else. So recently, on a marine mammal survey that we just did this past August, we found 2 separate pairs of right whales near Kodiak Island, and those are shown by those yellow stars. So the first sighting was on the 21st of August of 2 animals, one of which was confirmed as a new animal. So it's always really exciting when we can add an animal to our catalog. And the other animal was actually first sighted by DFO in Canada off of Haida Gwaii in June, a couple months prior. And DFO was able to get a biopsy sample from this animal. So we'll know the sex of it once those analyses are complete. And the other sighting was on the 24th of August and was found using acoustics. Again, we had one new animal that we added to the catalog, and the second animal was matched to catalog number 71, who was first seen in Barnabas Trough, which is about 80 miles away, in 2006. And this was the first time that this animal had been resighted. So it's always really great to know that, you know, some animals are still around, and in this case, showing some nice sight fidelity there. But the other thing, the other reason that these results were so exciting is that we suspect that the Bering Sea and the Gulf of Alaska right whales may be 2 different subpopulations. But our sightings are so infrequent that it's really difficult to determine if this is true or not. We have never matched an individual from the Gulf to an individual in the Bering Sea. And we've only ever had that one high to low latitude match from Hawaii. And prior to the survey, we've never matched an animal from the Gulf to anywhere else. But now we have a link between the northern Gulf of Alaska, and why is it? not advancing. There we go. So now we have a link from the Gulf of Alaska to the coast of BC. And so this suggests that perhaps these two subgroups have different migratory routes, where the Bering Sea animals may be heading south to Hawaii and the Gulf animals may be staying along the west coast. But with an N of 1 from both locations, it's impossible to make any kind of conclusions. So this is still a big unknown for us. So there have been a couple of new sightings recently that I wanted to tell you about. Hopefully this video is coming through okay. I see it's a little jerky. So at least 2 North Pacific right whales were sighted by cod fishermen just northeast of Unimak Pass in the Aleutian Island chain. And they got some really fantastic footage of skim feeding right whales. And to my knowledge, this is the first visually confirmed sighting of right whales feeding over winter in the Bering Sea. So this was a really important sighting. Because of this, we now know, or we got confirmation that at least some portion of the population might be overwintering in the Bering Sea and not migrating south. So unfortunately, the video quality wasn't good enough to match the animals to our catalog. So we don't know if they were new animals or known, but this was still a really exciting sighting. And then most recently, again, I hope this is coming through okay for you guys, a right whale was just sighted off Año Nuevo, California in April. This was originally reported by a recreational fisherman named Jack Gross, who again got this amazing footage of a skim feeding right whale. And again, while the video quality isn't enough for us to match it to the catalog, this is also a really important sighting, as I believe it's the first time a right whale has been seen feeding outside of their known feeding grounds in Alaska. And so while it makes sense that animals would take advantage of food whenever it was available, this is the first time it's been documented outside of their feeding grounds. Excuse me. All right, so what are some of the ways that we can identify what their migration routes are and try to answer those questions? Well, easy, satellite tagging, right? Why not put a satellite tag on it and track their movements? This has been really successful with other species. Varvara, the gray whale, immediately comes to mind. So we did that in 2004, and then again in 2008 and 2009. And while we did successfully tag several animals, and they provided us with some really fantastic information on their fine scale habitat use, unfortunately, all of the tags fell out of the animals before they left the Bering Sea. And so it left the question of their migration routes completely unanswered. So it was a really fantastic study, and we learned a lot, but not a whole lot about their migration patterns. So why do we still know so little about these animals? Why is it so difficult to study them? Well, if you look at the North Atlantic right whale, their entire migration route is along the US East Coast, right? At any given time of the year, you can head to the East Coast and see right whales. They are an extremely well-studied and well-known population because of that accessibility. Ours, however, are not the least bit easy to access. So to start, it's a full day steam to their high density area from the nearest port, Dutch Harbor. And the Bering Sea isn't known for having good weather. It can be downright grumpy at the best of times. And I think you can safely say it's difficult to spot anything in these seas, let alone a right whale. So even if we are in the area specifically looking for right whales, using acoustics to help us out, they are extremely difficult to find. And I always like to kind of break it down by the numbers to really kind of give you guys a sense for how rare they are. So I've been going to Alaska every summer for 12 years, skipped a year there because of COVID. And that amounted to 552 days in Alaska. But to be fair, a lot of those days were in the Chukchi Sea. So if we narrow it down to just those days when I was in either the Bering Sea or the Gulf in their historical distribution grounds, that's 419 days. But when you factor in bad weather, days where we heard them but couldn't find them, etc., what it boils down to is that of those 419 days, we've seen right whales on a whopping 22 days total. So for those who don't like doing math, I think that's only about 5.2%. And then we went 5 years on our NOAA surveys without a single right whale sighting. So that's the really big struggle. It's the proverbial needle in a very large haystack. And of those 22 days, we were only in their presence for a combined total of 69 hours and 45 minutes, which is the equivalent of 2.9 days over 12 years. But unfortunately, it kind of gets worse because you're dealing with the survivors of a population that was decimated by boats and by whaling. So whenever a vessel gets near them, they flee. Their behavior becomes erratic, they're visually cryptic. So even if you do find a right whale, usually the type of photos you get are of a really low profile whale, or you're in a thick fog bank where you can't see anything, or my personal favorite, the back of the whale as it swims away from you. So, how do you study a whale that only has 30 animals that you can't find, you don't know where it goes? Well, one of the best ways we can do that is using passive acoustics. So lucky for us, right whales are very vocal, and that makes them a really excellent candidate for passive acoustic monitoring. So our population of right whales primarily make 3 types of calls. The first is called a gunshot, and hopefully this comes through. I don't know that I can pause it, so we're just gonna have to let it go. Oh, there it goes. All right, so hopefully that came through. I can't see anyone's screen. I think y'all turned it off from bandwidth. Yep, excellent. Okay, so as you can tell, it's called a gunshot for a reason. Very impulsive sound. It sounds exactly like it's called. That is their predominant call type for this population. They gunshot more than they make any other call type. Their second most common call type is what's called an upcall. So I'll play that one more time just in case. Okay. And so we think this is a contact call between individuals, and those 2 calls are produced by all 3 species of right whales. They all produce gunshots and upcalls and moans, the next call type I'll play. But what's unique to this population is that they gunshot so much more frequently than they do any other call type for some reason. And then finally, the last call that they make, or call type, I should say, are moans, down sweeps, other tonal calls like this one. So I'll play that one more time. Hopefully my dog barking in the background didn't mask that for you. So those are the primary call types that they make. And so while we're at sea trying to find right whales, we will use an instrument called a sonobuoy. And so that floats in the water, as you see here, and the hydrophones hang down below it in the water column. And then that transmits in real time any sounds that occur. So if a whale starts calling, we hear it as it happens. And the other really great thing is that sonobuoys have directional capabilities. So then if we start hearing a right whale, we can deploy multiple sonobuoys at once, and we can actually localize or triangulate on their position and then lead the boat straight to the animal. So the screenshot that you see here, it shows 2 sonobuoys that are getting gunshots coming in. You can see them as the red kind of vertical lines. And then there's that gray map off to the right with those blue lines. Those are the bearings to the calls from each sonobuoy. And so our program will plot all of those bearing lines, and wherever they intersect, where that whale is, it'll pop up with the Latin long and the approximate distance and bearing relative to where the boat is. So we can do this and triangulate, excuse me, and then say to the captain, you know, there's a right whale 5 miles at 40 right, you know, go that way. And this has really been instrumental in helping us locate right whales and increase our number of sightings during our surveys. So then the other aspect of our research is long-term passive acoustic monitoring. So we have deployed year-long acoustic recorders at over 20 sites beginning in 2007. And these instruments will record to an internal hard drive for a full year, and then we retrieve them afterwards, and then we can analyze the data. So it's not in real time. We have to wait until you retrieve the instrument. But then by analyzing those data and by seeing which species are calling, we can then determine not only the seasonal presence of marine mammals, but we can kind of track migration and movement patterns as we compare the timing that the calls occur at all of these different instruments. And we can also tell whether that distribution is shifting as a result of climate change, which has been really useful in recent years. And so this has been one of the best tools that we have for monitoring for right whales year round, particularly because vessel surveys, A, can't happen all year round because of conditions, and B, they're just economically not really feasible a lot of the time. And so I wanted to go through some of the results from our long-term monitoring. So this plot shows right whale calling just over 2 years at one location. And so the black lines are right whale calling presence. So right here, it's a percentage of 10-minute intervals with calls per day. So 100% calling activity would be that every 10-minute increment of recordings for that day had at least one right whale call. And the blue line is percent ice concentration, and then any gray sections are where we don't have data. And so with this plot, you can see that we have consistent right whale calling in the summer and fall months. But then if we zoom out, we can include multiple moorings, multiple years. So now we're looking at 9 locations over 6 years. I've color-coded the moorings based on the circles on the map to the left, and I've tried to arrange them latitudinally just to make it easier to kind of conceptualize. And so this is a really nice example of some of the long-term time series that we can get relative to right whale detections in the Bering Sea. And so what you'll notice is that we have consistent annual detections of right whales in summer months in the southeastern Bering Sea, particularly in their critical habitat, which are the bottom 2 of the highlighted ones. But what we've also noticed in recent years is that we're starting to get an uptick in our detections in the northern Bering Sea that we think may be due to oceanographic conditions. And I'm going to get back to that in just a little bit, because like with all things with right whales, there are complications and challenges. So I mentioned that right whales produce gunshots and upcalls. Well, so do bowhead whales, because of course they do. They also will gunshot and make upcalls that are impossible to distinguish spectrographically or aurally from right whales. So this plot here shows almost 4 minutes of recordings from a northern Bering Sea recorder in mid-March under 100% ice cover. And most of the calls you see on the spectrogram are bowhead whale, but right in the middle of all this bowhead whale song are 3 textbook right whale upcalls. So were these made by right whales or were they made by bowheads? And that's one of the questions and the problems that we have. So if you go back to our plot of the long-term acoustic detections, all of these detections that are highlighted in red occur under the ice in winter when bowheads are also present. So these are those calls that by definition look exactly like a right whale upcall or are gunshots, but that we have to just mark them as ambiguous or maybe, because we don't know whether they were produced by right whales or bowheads. Okay, so how do oceanographic conditions influence right whale distribution? Well, Zerbini et al. Found that during strong cold regime years, or what we call a cold pool year, in the summer, right whales had much more restricted movements and used a much smaller area within their habitat, as you can see in the middle in the right-hand panel. But in years where that cold pool was weak or not present, like in that left-hand plot, their movements were more widely distributed. And he hypothesized that the cold pool concentrates their zooplanktonic prey into a much smaller area, whereas warmer conditions resulted in their prey being much more widely distributed, and therefore, by extension, the whales themselves. And as I'm talking through this, it occurs to me that you may not understand what the cold pool is. So very briefly, the cold pool is basically a cold bottom layer of remnant winter water. So it's all that really cold, really fresh winter ice water that remains down at the bottom. And in cold water stanzas, that cold pool is really strong, as you can see in that far right-hand plot. But in years where there's warmer temperatures, earlier ice retreat, that cold pool of remnant winter water is either not there, or it's greatly reduced, or it's restricted only to the northern Bering. So that's what we mean by cold pool. Yep, and there you go. More widely distributed with restricted movements. And so the one thing that I'm asked a lot is, how is climate change impacting this population? And while we're still trying to fully understand all of the impacts of a warming and changing Arctic on this population, there are some pretty evident trends that we can look at now. Most notably, a lot of studies have shown that the warming temperatures and that early retreat of sea ice in the Bering that we're seeing more and more often is resulting in a decrease in abundance of the large lipid-rich zooplankton that they need. And that not only are the zooplankton much smaller, but that they have less fat content. And so this plot shows the changes in abundance of various classes of zooplankton in the northern Bering, which are the left-hand 3 plots, and the southern Bering, the right-hand 3 plots. And I've added the color coding shading to represent the warm and the cold stanzas. And so you can see that warm years result in fewer large copepods throughout the entire Bering Sea, and then they tend to favor those smaller, less lipid-rich copepods. And so if we look at our long-term data series now through this lens of oceanographic data and what it means for those zooplanktonic prey, I've now highlighted those sections where it was a cold stanza or a warm stanza. And you can see generally those years with warmer conditions were the years where we had more acoustic detections in the northern Bering, which corresponds both with the zooplankton data as well as with the Zerbini et al. Results. So with climate change, we could be seeing both a decrease and redistribution of their prey, and by extension, a redistribution of the whales further north. And this corresponds really nicely to the right whale sighting reports that we have received from Alaskan natives. While there was one sighting that occurred during the cold years, there have been quite a few reports, especially in recent years during the warm period, with right whales around St. Lawrence Island. And this, again, it corroborates the Zerbini et al. Paper really well. So we're starting to see these really clear trends of how climate change may be impacting their prey and their distribution. But climate change isn't the only threat these animals face. One of the biggest threats is the possibility of entanglement, as you just saw with Gary's presentation on the entangled gray whale. Alaska does have one of the largest fisheries in the country by volume, with pot fisheries occurring for many species, not only crab, as you would think, but several finfish as well. And while there have been very few individuals photographed with entanglement scars, this animal here was one of the only ones that we have in our catalog with scars. This is from the Ford et al. 2016 paper that was cited off British Columbia. But the rarity of sightings of these animals combined with the extremely remote location means that it's unlikely that an animal that is entangled would be sighted before it dies. So while this is certainly a really big threat, the actual impacts to the population have been really difficult for us to quantify. And another big threat is interactions from vessels, either from those fishing vessels or from commercial shipping. And so some of the work that's being done by our team member, Dana Wright, is to look at right whale presence in two high traffic Aleutian passes, which are shown here by those yellow stars. The one on the right is Unimak Pass, and the one on the left is Umnak. And so when you overlay those two locations of our recorders over a map of vessel traffic, it presents a pretty staggering picture. So this map is a density map showing all the traffic in 2020. And then the green vessels are obviously all of the current vessels in transit. And the Great Circle Route for commercial shipping, it runs right through Unimak Pass, which we think is one of the main passes used by right whales when they're migrating to and from the Bering Sea. So these plots show the acoustic detections from those two recorders. So on the left-hand plot, you've got the right whale calls detected at Unimak on the top and Umnak on the bottom through 2017. And the right-hand plot, which I think is even more telling, it shows right whale detections at Unimak Pass overlaid with that vessel noise, which are the gray vertical bars. And Dana's currently working on an updated publication that will include the more recent years, the past 4 or 5 years, whatever it is. But I mean, you can see there wasn't a single day, I think, where there was not a substantial amount of vessel noise detected at Unimak Pass. And so this is obviously a really huge threat to this population as they migrate through this narrow choke point. But again, the actual impacts have been so hard to quantify that we can't say with any certainty exactly what effect it's having on the population. So as a way to help mitigate this threat, in March, the Center for Biological Diversity and the Save the North Pacific Right Whale organization together submitted a formal petition to the Department of Commerce to expand the right whale critical habitat based on recent and historical sightings. So these two polygons here in red show the current critical habitats that were designated by NOAA. And this petition that they submitted is now asking for it to be expanded to include all of that area here shown in red. So it'll basically connect the two current habitats and encompass the area south of the Aleutian Islands and then going up through the passes and to the west of the current Bering Sea habitat. And so this petition, it's currently under review by us and by other NIMS offices to see whether it warrants a formal review. So stay tuned for results on that. That'll be in the next talk. Excuse me. All right, so I want to talk about, there's a bug in here. So I wanted to talk about some of the other research that we're doing as well. So one of the long-term goals that we really hope to achieve with passive acoustics is being able to get abundance estimates just using your passive acoustic data. And so to do this, you need two things. You need the calling rate of an individual right whale, which is really difficult to get because, as you can imagine, it would vary based on season, behavioral state, group composition, et cetera. And you also need call counts, or the number of calls total over a certain time. But boxing those individual calls or getting those call counts can be very time consuming, especially when you factor in 12 sites in the Bering Sea over 15 years. But Dan Woodrich at our group has developed an automated detection system, an algorithm that can box individual gunshot calls. So hopefully this will save quite a bit of time in obtaining those call counts. And so then if you have those calling rates where you know how many calls per hour an individual right whale makes, and then you know the number of calls you have per hour, you can then get at how many animals are calling and get a rough abundance estimate. So we're still working on getting that calling rate. We try to get that every time we go out into the sea or out into the field. You know, you need to have concurrent visual and passive acoustic data collection at the same time. And we've started to do this. We have a few data sets, but we have a long way to go yet. We don't have any reliable numbers just because our sighting rate is so low. So that is hopefully one day we will get to that point. We're not quite there yet for this species. One really interesting that we discovered a few years ago was that our small population of right whales sings. So they make these patterns of gunshot calls that are being produced in a manner that is very similar to humpback whale song. So they have this hierarchical structure where several gunshots will produce a phrase, several phrases will comprise a theme, and then that in turn creates a song that's repeated for several hours. And so to date, we have found 4 unique song types that you can kind of see here, all that are comprised almost entirely of gunshot calls and overlapping with other right whale detections. And so far, this hasn't yet been documented in other right whale populations. And right whales are known to use sperm competition as their mating strategy. So we have no idea why this, the smallest and most endangered population, is singing, but we find it fascinating. And we have so many questions about this. Not only have we found 4 different song types so far, but the songs themselves have demonstrated really long-term stability. So the same song has remained consistent over the 8 years of the study. And this song was also localized to 2 confirmed male right whales. So we know for sure that males sing. We don't know yet whether females do. So we suspect that this might be some kind of a reproductive display, like you see with the songs of other species. The other thing is that this gunshot song, or this patterning, hasn't yet been seen with bowhead whales. While they do gunshot, it's much less frequent than with right whales. And bowhead songs are comprised of tonal calls or other call types, but not gunshots. So this might be a way for us to distinguish between species during periods when there's that ambiguity or when they overlap. And not only that, but if our colleagues that have recorders in other locations, like along the West Coast, if they detect this gunshot song, then as of right now, that is a very clear indication that you have a right whale present. And so we're hoping that this will increase our extraliminal detections of right whales and help us answer some of those questions about where they're going. And then most recently, on that Gulf of Alaska survey I mentioned earlier, I detected song during our second right whale encounter, but it was slightly different than the Bering Sea version that it most closely resembles. And so we're still analyzing our current Bering Sea data to see if this new song version also occurs there, or if it might be unique to the Gulf of Alaska. But, if it is unique to the Gulf, then that just raises so many really fascinating questions about song production in this population and transmission within the species and between the 2 stocks. So again, stay tuned for more results on that, where we hopefully have some really exciting news. So another really exciting possibility is coming this summer when I head back out to sea. The International Whaling Commission conducts an annual survey throughout the North Pacific called the Power Cruise. And it's primarily a visual line transect survey. But beginning in 2017, they started surveying the Bering Sea. And so we added acoustics for the first time on these surveys to help in locating right whales, because they were going to be right through right whale critical habitat. And so between 2017 and 2018, we found and photographed a combined total of 15 right whales. We biopsied 6, we recited 9 known individuals, and we added 6 new individuals to our catalog just in those 2 years. It was absolutely incredible results. So this year, we are surveying the area south of the Aleutian Islands, in that area in purple that you see on the top right plot, from approximately Umnak Pass to the EEZ border. And so there's a possibility that we may see a western right whale when we're in the far southwestern corner of the survey area. If we see one and I'm able to record any vocalizations they may be producing, then we can compare that to our data set in the Bering, in the Gulf, to see how similar their calls are between the 2 different populations. And if there is a difference, then we now have the ability to differentiate between those 2 populations in areas where they may overlap on our recorders, like the Northern Bering. So this is a really exciting opportunity. Fingers crossed for a Western right whale. Really will be fascinating to be able to see one of those. So another internationally collaborative study that we're working on is working with DF
Is being recorded.
You guys still got me? Are you still
Yes.
there? Okay. Sorry, that was my VPN kicking me off and disconnected. Apologies about that. So we're working with DFO Canada to analyze some of their moorings for right whale calls. So we're hoping that it might provide insight into their migration patterns and the routes of right whales. So we're analyzing these moorings using that automated detection system that I mentioned earlier. And this is also a nice proof of concept project to determine whether an auto detector that was designed for the Bering Sea could be implemented in a different area with potentially different species. And if this proves successful, then this may then allow us to very quickly analyze large data sets in other locations as well. So it's a really neat project, looking forward to results. We have detected some right whale upcalls on a few of the moorings. We're still working on ground truthing some of the gunshot detections, but really exciting preliminary results coming from that.
Jessica, we lost
Yeah.
your screen share. You'll have
Oh,
to
no.
reshare the screen.
Okay, let's try this again. Thank you for letting me know. Luckily, I don't think I advanced the slide at all, so didn't miss too much. All right, great. Thanks, Paul. Let me come back over here. All right. And so these next few slides are all going to be describing the work being done by our team member, Dana Wright, as part of her PhD research at Duke University. So all credit for the awesome research in the next few slides goes to her. And if you have questions about this, I'll do my best to answer, but I may just have to send you over to Dana for that. So, you know, again, we keep saying that one of the key things missing in our knowledge is their migratory patterns. And so Dana is really hoping to explore this using stable isotope analysis. So by measuring stable isotopes in baleen, you can get a continuous multi-year ecological history of an individual. So as they migrate and they prey on, or as they eat prey from different areas, those stable isotopes and those nitrogen values will change. And so you can see with this Kodiak male right whale in the right, you can see those oscillations that support a migration in between those different latitudes. And so she's also recently obtained baleen plates from Kodiak from an unknown species and is currently working on trying to identify the species of those baleen plates, whether they were right whales or bowheads or some other species to hopefully add to her data set. So in addition to the isotope work, she's hoping to leverage some of the lower trophic level data sets to explore where right whales may be on the Bering Shelf where we don't have acoustic recorders. So right whales feed primarily on Calanus copepods, which are also a predominant prey species for a lot of forage fish species and from which samples are much more readily available. So she's hoping to determine if these lower trophic level data sets can be used in a joint species distribution model to conditionally predict where right whales may be on the middle and outer domains of the Bering Shelf. And then from this, we can then better target our acoustic monitoring efforts. So we've mentioned there's this ambiguity in the call types between right whales and bowheads. So she's hoping to, she's using this technique called nonlinear time warping, where you do some fancy physics with the calls and you pull out these different modes that you can see. They're numbered 1 through 5 that are effective propagation. And by doing this technique called time warping, you can actually get the range and depth of the calling animal. And so we think that bowheads and right whales will call at different depths, where bowheads tend to call in deeper waters and right whales tend to call in more shallow waters. And so if we can use this time warping method on those gunshots and determine whether the caller was shallower or deeper, that may give us some clue as to the species that's producing the call. And then finally, she's working with graduate students at Duke University to attempt to use machine learning to automate this time warping process, because it is such a time intensive process to do. And so she's hoping that she can develop some kind of a machine learning system to automate this. And then the added benefits of this would be that we could then apply this to all the detections going back through our entire data set, and potentially then obtain that abundance estimate that we were talking about, as well as estimate recorder detectability and quantify the impact of noise on right whale detectability, which is still not really well understood. The really exciting stuff coming from her research. And so the one kind of last aspect of our research that I wanted to highlight was our attempts to increase our outreach efforts and spread the word about this animal. You know, opportunistic sightings are so valuable for us, and we really do rely very heavily on sightings and reports of right whales in other locations, particularly since we can't be out there surveying all the time. You know, anyone out on the water can be eyes for us. And these sightings really help to increase our knowledge of their spatio-temporal distribution. And so you remember that February overwinter sighting that I mentioned? Well, within a few days, we had worked with colleagues from several branches of the government to get a Coast Guard notice out to mariners to keep a lookout when they're in the area, as well as an automated AIS notice. So whenever vessels entered that blue polygon you see on the map, if they had AIS going, it would automatically alert them to the presence of right whales and asking them to slow down and keep an extra lookout. So this is just a really fantastic example, not only of the benefits of collaborating with industry, but it also, I think, highlights the need to raise awareness about the species. The reason we found out about it is because the cod fishermen submitted a photo to our colleagues at Alaska Department of Fish and Game saying, hey, what is this? We have no idea. It looks weird. It's not a humpback. And so this, again, it's really, really important. This is a photo of a right whale that was sighted off La Jolla in April of 2017. Some of you may remember this. It's a beautiful shot of the pectoral fin, right whale on its side, right? Well, this is the whole photo that was aired during the news segment that evening. You know, this whale was originally identified as a gray whale, and it wasn't until aerial photos from drone footage emerged about a week later that it was correctly identified as a right whale. But unfortunately, by that time, the whale had already left the area, so we weren't able to get any clear photo ID photos from this animal. So, you know, this begs the question, how many other whales have been misidentified as a different species? How many sightings may we have missed? And so perhaps with more public awareness and more correct identifications, we may get more sightings outside their known feeding grounds. And these extraliminal sightings, again, they really help us to put together a few more pieces of the puzzle. All right, so what can you guys do? The biggest thing is to just help us spread the word. You know, tell anyone and everyone who is willing to listen to you that these guys exist. The more people that know about right whales, the greater the likelihood of us getting sightings and more reports. I mentioned we're working on expanding our outreach efforts. We're now including, you know, whale watch companies, recreational and commercial fisheries, scuba diving operations. You know, anyone that's out on the water could be eyes for us. So, you know, I have a lot of materials. I've got flyers and handouts and bookmarks and stickers and you know, all kinds of swag that can be distributed. I'm happy to share and send some if you guys think that you want some, or you know a great place where you can distribute them. Please let me know. I'd love to get stuff in the mail for you guys to send out just to help us get that word out. And then finally, I just want to wrap up by mentioning what to do if you see one. You probably all know that's why you're here. And obviously, please follow all regulations for the animal's safety, slow your speed, and stay 500 meters away because they are critically endangered. Any photos or videos are extremely helpful. If you can get an ideal photo of the side of the head, like the one shown here, that's fantastic because that gives us then a photo ID quality photo. We can see if it's a known individual in our catalog. But even as you saw from the videos of the fishermen, even non-photo ID quality photos and videos are extremely helpful for showing behavior, confirmed species ID. And then please let us know. We have a sighting email that's set up, np.rw@noaa.gov. You can email me. You know, helpful information is date and time, the location, number of animals, if you know its behavior or you can tell what it is. And even if you aren't sure if it's a right whale or not, it's kind of a fuzzy photo from far away, still send it to us, right? We would much rather have a whole bunch of false alarms than to miss a possible sighting. So it's, yeah, anything you guys can do. If you happen to see one, please let us know. We live for those sightings. I love getting emails about a new right whale sighting. And that's it. That's all I have. Thank you so much, everyone, for your time tonight, for sticking around, and for letting me speak with you. And with that, I will happily take any questions that you may have.
Hello. I don't know why my big face is showing up there. Nobody got time for that. Dennis Kelly. Hi, Dennis Kelly. He'll be speaking at the Catalina Conservancy on behalf of ACS, or is coming up in the very near future. So check that out if that's online too. Dennis said, is there any evidence of right whales passing through the Northwest Passage, either west to east or east to west? And
we have not had any evidence yet. It's certainly not out of the realm of possibility, but so far there has not been any evidence that we know of that they've made it that far. So let's hope they kind of stay in their respective areas.
Okay, and Tamarin, I was wondering too, what percentage of the Bering Sea doesn't freeze, say pre-climate change?
Of the Bering Sea shelf, so the ice would go all the way down to their critical habitat. We would get ice regularly at our M2 mooring within the critical habitat. So, I mean, off the top of my head, I'd say only about 20% was not ice covered pre-climate change.
And now?
Now it's pretty bleak. The ice is really only going down to kind of the mid shelf. The ice that is coming there it's thinner. We used to get really nice dense multi-year pack ice, and now we're only getting the kind of the thin single year ice. It's retreating sooner. And one of the really unique things about the Bering, and one of the reasons it's so productive, is because you get that winter sea ice that comes in. When it melts, all the algae that accumulates underneath will then fall to the bottom, and that's what drives that production bloom that then feeds the ecosystem throughout the summer. And as that ice retreats earlier, there's less algae that's falling. You're getting more mixing and less stratification. So it's shifting the entire ecosystem from, you know, these large copepods that then feed seabirds, marine mammals, forage fish, to your smaller copepods and more phytoplankton dominant.
Okay, yeah, I know that's affecting gray whales and everything that's feeding up there too. So, you know, we talk about that one. Do storms, especially in winter, do they change the quality of your acoustic information that you receive, or is that deep enough that it's not that effective?
We'll get an increase in ambient noise a little bit, but it's not enough for it to significantly impact our ability to detect right whales. That's more an issue with vessel noise that's been increasing over the years.
Okay. Yeah, Sonic Sea is a good one to watch in case anybody hasn't seen that one yet. And then Natalie, who was the one who saw and identified the gray whale. Any estimate on the North Pacific bowhead populations? Is there any possibility of bowhead and right whales any hybrid?
Well, the first question, which is easier to answer, I believe the population is estimated to be around 15,000 or so. So they're doing well, and they're a nice, healthy, sustainable population. Regarding a right whale bowhead hybrid, I sincerely hope not, because it would make our already difficult job even harder. Again, I think it's very possible. They are genetically pretty similar. They're both in the same family. We have heard reports from some of the indigenous peoples that they have a whale that isn't quite a bowhead, but isn't quite a right whale. Without photos, we can't say for certain one way or another. So it's certainly possible. There haven't been any documented hybrids. But again, I hope not.
Okay, yeah, for your sake, it would be interesting for us to see that, but okay. Those are all the questions. I'm sure people have a ton, but they're being so respectful of a woman with COVID doing a presentation. That's how much you love these right whales, right?
I do. I love them. Like I said, I would happily go on and talk for hours, but I didn't want to bore everyone too much. And I'm sure a lot of it was repeat for some of you. So
there's a few questions, Jessica, in the chat.
yeah.
Okay.
There are one, Christy Dickinson is asking how many right whales are in the Atlantic, and is there a population off of South Africa?
So in the Atlantic, they are somewhere now around 350, I believe. They've been steadily declining, unfortunately. That's the benefit of them being coastal is that they are easily accessible, but the downside is that they are right in the middle of all of the fishing grounds and shipping lanes. So yeah, their population, they know exactly how quickly it is declining. They are currently around 350, I believe, at last count. And then South Africa. Yes, so there are several different kind of populations within the southern right whale species. There are some around South Africa. I've actually seen one. It was very exciting. So I've seen 2 of the 3. I have yet to see an Atlantic right whale of all the right whales. So there's a population around South Africa. There's another one around Brazil. Yeah, there are a few different stocks in that species.
Okay, and then we've already got some board members saying we could use some of those materials, handouts for our table events and stuff. So send
me an email.
Okay, I promise I will. And
yes.
Diane Alp says, you're amazing, Jessica. Feel better soon. So I think we all say feel better soon. So thank you. You get to be the first person ever to do one of our speaker series while currently having COVID. So there's a wonderful designation. There's got to be some sort of trophy for that, right? Like a jar of slime that you can make noises with. Okay. Okay. Anybody else? That's it. Great presentation. Thank you so very much for your time, and please go curl up and feel better very soon.
Thank you. And I appreciate everyone not hounding me with a ton of questions. I'm very happy to answer them. So please don't hesitate to reach out. I have a whole bunch of really weird, random right whale facts and trivia, and I'm happy to share. So please don't hesitate to reach out at any time.
Okay. Thank you so much, everybody. And I think next month we'll be in person at OCC, and Elisa Schulman-Janiger, I think, is going to be giving us a gray whale census overview for every year that she's ever done it. So it should be fun. And it's great seeing her recall all those facts just verbatim too. So that'll be interesting. So we'll see you at OCC next month. Thank you very much for attending. Good night.